So yeah, I'll be talking about MEP 2040 challenges, solutions, and what we think could be industry implications. Quick agenda, why we signed on to the commitment, what does it mean to actually achieve this, what metrics are being defined, some findings from initial research that we've done through a fellowship with the Energy Trust of Oregon, and how we're trying to scale for 2030 and 2040. So we have a commitment as a company. Our vision is a world with clean air, energy, and water for all. And we were excited when the MEP 2040 Challenge came out because it aligns really well with us. And we have signed on to it. So the link is here and available if anybody else is interested in signing on and seeing more details on what's in it. And why we're doing it, we see emissions as atmospheric pollution. We feel like it's often not discussed in this term, but with the current administration, you might have heard there's discussions around changing emissions to not be a source of pollution. And just a reminder that energy use is a proxy metric, but carbon emissions and carbon pollution is really the thing we're trying to fix. So what does it mean to achieve this? For 2030, we're targeting net zero operational emissions. That's coming up really quickly. At the moment, we're using the national definition of zero emission buildings, and I'll get into that. And there are a bunch of questions that come out of like how you define net zero operational emissions. And MEP 2040 currently is pretty open in how this is defined. Same with net zero embodied carbon. There's a bunch of questions come up in terms of reduction targets, refrigerants, offsets, and I'll get into at high level some of our findings today. So from an operational carbon perspective, for us, what it means to achieve this is to be advocates for highly efficient, grid interactive, all electric designs. Try to maximize on-site renewables where it's feasible, and to try to have clean electric grids and grid interactivity. The current MEP 2040 commitment doesn't really talk about grid interactivity, but from our perspective, that's crucial to really solve this. So we're starting a process of tracking our project's efficiency and carbon impacts. We're ramping up training and standards on grid interactive buildings and all electric designs. And we're trying to target our current metric that we started using is 80% of our projects meet DOE zero emissions by 2030, and 80% of our projects to be all electric by 2030. Now, you can see this is a little different than the MEP 2040 commitment overall, and I'll explain why in a little bit. But one of the most interesting questions I think that comes up when you look at this is, when is zero zero? And all of these different standards or goals are trying to get to net zero carbon, but the zero emissions from Department of Energy, their definition has its own baked in assumptions. Architecture 2030 and AI 2030 have their own assumptions. And then ILFI zero carbon as well. And personally, I don't believe any of these are truly zero at the moment. They're moving towards zero, but we're not truly at zero. So within the DOE national definition on zero emissions, if you're not familiar with it, they have this criteria that a building must be energy efficient, so one of the most efficient in its category, no on-site emissions except emergency backup, and it's powered by clean energy, 100% of energy from clean sources. And it benchmarks to Energy Star. So for an existing building, Energy Star score greater than or equal to 75, and new buildings would be greater than or equal to 90. And then there's some other pathways to get there. And carbon offsets are not allowed. When you look at Architecture 2030 and AI 2030, using the zero tool, I used just an office building, 100,000 square foot test to see, for the benchmark, where would the baseline be and what's your target? And I think as an industry, we're really used to talking about energy, but emissions, it's still, there's this wide variation in how we define the metric. And even down here, you can see the way that emissions were reported, it does vary by region, and it ties back to eGrid. But there's a bunch of underlying assumptions under the hood that drive those emissions assumptions, and they don't always align well with how the benchmark's tracking it. Here's a quick table looking at the three different systems comparatively. So from an energy efficiency perspective, each one of these has some kind of energy efficiency requirement. For on-site emissions, there's variations. AI 2030 allows fossil fuel use until 2030, then it needs to be zero, whereas the other two don't allow it. For clean energy supplies, there's variations in terms of where it's coming from. Some have Green E climate protocol for RECs. Traditionally, Architecture 2030 had a limit of 20%. The newer AI 2030 system has a way around that. And then carbon offsets, it varies as well. And ILFI has its own definition. So you can see there's just a lot of different ways of measuring zero. And most of you are probably aware of that. But as an industry, we really need to try to figure out like how do we find alignment and start scaling this. Additionally, for embodied carbon, it's similar dilemma in terms of each of these stages, in terms of how you're tracking it. And we're excited for the new 240p standard to help normalize some of this across the industry. So findings from our research, we did a research paper on refrigerants for the city of Seattle and the C40 back, it was published in 2020. This is a link to it if anybody wants to go check it out. There's a ton of detailed refrigerant information in there. We did a bunch of scenarios with different building types, different mechanical system options. We had different charge rates, leakage rates, and the big finding for projects is whenever you have site-built components with like a VRF or mini split, with traditional like 410A refrigerants with high global warming potential, the risk of emissions from leakage can actually be pretty significant. So the vertical axis here is refrigerant use intensity, pounds CO2 equivalent per square foot per year. And the key, like the real solution is trying to find natural refrigerants or really low GWP refrigerants, because at that point leaks don't matter very much. But the industry still has a ways to go for adoption of newer refrigerants and equipment. From the Energy Trust of Oregon perspective, we had a grant where we had a small stipend for an intern. We've had an intern in our office for the last quarter who's been tracking our emissions from Oregon-specific projects. And as part of that, we created a MEP 2040 reporting table. This is kind of like the SE 2050 tool. We decided to not go through the DDX, and I'll touch on that in a little bit. We were using Energy Star Portfolio Manager, and then we have our own refrigerant calculator that looks at different leakage rates. The thing for an MEP firm that's different than, potentially like an AIA for an architecture firm is often a lot of our projects are minor equipment replacements, minor remodels, or other. So in this scenario, you can see what we're counting as MEP 2040 eligible are major equipment replacements. So anything that's looking at fuel source changes, major remodels, and new construction. So we started with 176 active projects. So we kind of pulled from all our projects in Oregon. We found that 81 of them were MEP 2040 eligible. So you can see the majority of our projects are actually all these small changes. So it could be some minor ductwork distribution updates that do not technically have a huge impact for MEP 2040 overall. And then we looked at the number that had energy models and then the number of ones with refrigerant data. And this was really focused on lead specific. Without lead, there is not a formalized way for tracking it typically on projects. So this was interesting. For scaling to 2030, what we're trying to do right now is advocate and deliver projects that have highly efficient, grid interactive, and all-electric designs. So we're trying to figure out how to make the case on all of our projects and truly deliver it. So we're working really hard. It's our first strategic initiative over the next 5 years to try to scale this and advocate for it on projects, because we see, even though we don't have control over what a project does, we can still show what's possible and hopefully make a viable enough case to get way more projects moving in this direction. Additionally, offsite renewables is something that not all of the standards look at holistically, but we're trying to find balances for offsite options as well. And then, yeah, a lot of training, because to scale it up, you can see kind of back to this, like we need to get not 25 or 4, but at least 80 or potentially all the way to 176 with all those little projects once we get the big ones taken care of. For the embodied carbon workflow, there's even more work to be done. So we're working on integrating our embodied carbon analysis in all of our projects. We've developed our own internal MEP embodied carbon tool that we can pull data out of Revit drawings and also early analysis to try to size or estimate the impacts from an embodied carbon perspective. EPDs, we're ramping up education across all of our departments, so our mechanical, electrical, plumbing, and technology teams. We're updating our specs and coming up with standard work plans for EPDs and LCA declarations. And I think in the next 5 years, there's a lot of work to be done just to ask for these from manufacturers. So then, to Ifri's point, more manufacturers have the incentive to create them, and then we can start to move the market in the right direction. Similarly, on refrigerants, we're advocating for low GWP refrigerants, but also educating clients about leakage risks. We've been doing this for probably the last 8 years, and when we started, it was new information for most people we would talk to about risks of leakage of refrigerants. So now it's great. It's far more widespread and people are understanding it better. And then just tracking refrigerant quantities, both into the design process. So we're working on getting that in our drawings and our narratives. So every drawing has it. And then also for post-occupancy, the clients are tracking it properly, because it's common that they don't track it. And that's my really quick presentation. So thanks.